Good morning everyone, I am Mr. Ish. We're continuing here with this topic on vectors. Here is our third video on vectors, but we'll be focusing on adding vectors, but not via the numerical method. We'll be using the triangle and the parallelogram method. This is just a pictorial method for adding vectors, and this is something you have to know, even though it may not be very relevant in terms of being practical, but you still have to know these two methods. Everything I'm showing you over here will apply to non-collinear vectors. Non-collinear vectors or collinear vectors has nothing to do with the size, it has to do with the direction. Non-collinear vectors are vectors which are in different angles with relation to each other. You cannot overlap them in any way. Think about these two markers as being vectors. A non-collinear vector would look something like this. You cannot overlap them in any way. They just don't fit on top of each other. If you contrast non-collinear with collinear vectors, these are vectors which can easily overlap. Their direction is always the same, or it's exactly the opposite. This is what a collinear vectors would look like. You have two vectors, they fit right on top of each other because they're in the same direction, or they can be in exactly opposite direction but they fit on top of each other. It doesn't matter what the angle is, but they both overlap each other and cover each other very well. That's a collinear vector. But everything we're looking at over here is to do with non-collinear vectors. And very quickly, previously we've seen that if you have a vector u and a vector v, you can add them up by adding their individual elements. u1, v1, they're added, comma, u2 and v2, they're added, and what you get is called a resulting vector, or is resultant. The resultant is a vector, and it indeed has its own components. This r1 is u1, v1, and this r2 is u2, v2. And of course, if you have something which looks like this, then you can, in itself, you can determine its magnitude and its direction by means of the two formulas I presented, the arctan y over x, or the Pythagorean style formula, the sum of the individual components squared, and you square root them. So you can do all of that. You can do the magnitude of the resultant, and you can do the direction of the resultant. All of that can be determined. But let's get to our topic over here. Remember, our topic here is non-collinear vectors. We're going to be looking at how you can add vectors using the triangle and the parallelogram method. These methods are not hard. They could be a little confusing at the beginning, but they're not hard. Consider you have two vectors over here. One is u, and it looks something like this, and the other vector is v, and it looks something like this. They're non-collinear. You cannot add them on top of each other in terms of cleanly overlapping one another, but you can certainly add them, and each of these you can easily determine their length and magnitude. You would just put them on an x and y axis and determine their angle, and you determine their size, and all of that can be done. But we're not doing any of that. We're doing the pictorial methods over here. We look at the triangle method first. To do the triangle method, you take your one vector, the first vector, and then you add to that the other vector, and you end up with a triangle. And I'll show you. And you have to draw them exactly as you see them, in the same size and in the same direction. The u vector looks something like this. Then from the tip of your u vector, or the end of the u vector, you draw exactly the v vector as you see it, in the exact same direction. Here's my u, here's my v. Then from the start of your u to the tip of your v, you draw a line, and that line over here represents your resultant. And your resultant vector would look exactly like this. If you were to mathematically add this, you would exactly end up with this. This right here would be your resultant vector. That right there is a triangle method. You basically start with your first vector, then from the tip of your first vector you draw your second vector, then from the beginning to the tip of your second vector you draw a resultant, and that right there will give you a good idea in terms of the math behind it, the size, the magnitude, and the direction. For the parallelogram method, it's a relatively simple process, but in both methods the resultant must look exactly the same. We saw a resultant which looks relatively like this. When we use the parallelogram method, we must end up with something which looks the same. Both of these are two different methods, but the outcome is always the same. For the parallelogram method, you start with your first vector, here's my u. Then from the base of the first vector, you draw the second vector exactly as you see it. From the base of the first vector, here's my v. Now you have to draw a parallelogram. Try to make a good parallelogram, two pairs of opposing parallel sides, right? From the beginning now to the intersection of your dashed lines, you draw what will be your resultant. This was the resultant from the triangular method. This right here is the resultant from the parallelogram, and they must be equal. So you can see exactly how these methods work out. In the parallelogram method, you draw two vectors, but they both start at the same point. You draw a parallelogram, Then from that origination point to the intersection of your dashed lines, you connect that to make your resultant. Alright, our first question over here is this. U looks like a vector, which is this. V looks like a vector, which is that. And we have to find the resultant vector using the triangle and the parallelogram method. We'll do the triangle method first. To do the triangle method, you draw the U vector first exactly as you see it. Then from the tip of the U vector, you're going to draw your V vector exactly as you see it with the same dimension. That's your V vector. Then from the beginning of your U vector to the tip of the V vector, you connect it, and that right there is your resultant. The triangle method is complete because you've ended up with a triangle. Now let's do the same thing with the parallelogram method. With the parallelogram method, draw the U vector exactly as you see it, same direction, same everything. And then from the very beginning of that U vector, draw the V vector as you see it, and there it is. Now try to draw a good parallelogram, right? And from the beginning to the intersection of the dashed lines, connect the two, and here's your resultant. This resultant by the triangle and this resultant by the parallelogram must be identical, and you end up with a parallelogram here, you end up with a triangle. So in both instances, these answers look good to me. Both of these answers will represent exactly what we're showing here, U plus V, the vector addition. Alright, our second and last question is this. We have vector U, we have vector V, we have to do U minus V. Now if this minus creates a confusion, you can always view it as this U vector plus and then minus V. And now you're thinking about what you learned in the previous video, where you can apply a coefficient to a vector and hit everything in that vector with a minus and flip it around. You're essentially going to convert V into a minus V, and minus V will look something like this, exactly the same but in the opposite direction. There's your minus V. That's the effect of a minus V, just flips everything around. Now you can add both of these using your triangle and the parallelogram method. Let's do the triangle method. Draw U exactly as you see it. Here's my U. From the base of U, let's put the letter right over here. From the tip of U, you draw V in exactly the same manner and form that you see it, and that's right there, V. Now connect the beginning of U to the tip of V, and that right there is your resultant, and it looks like that in that orientation. Now the parallelogram method, you do exactly the same with regards to your starting with the U. You draw V from the very beginning of U as you see it, and it comes out looking like that. And what you end up doing is drawing a parallelogram, but here the parallelogram very well is what? The parallelogram here is a rectangle. Rectangle is a parallelogram, two pairs of opposing parallel sides. Connect the beginning of the U and the V vectors with the intersection of the dashed lines, and that right there is your R. This R right here, this R should be identical in all instances. The magnitude, which is the size, and the angle. So both of these representations look good. You have a triangle here and you have a parallelogram here, except the parallelogram is a rectangle. But anyhow, both of these answers are right. So don't let something like this confuse you. If you have a minus, view it as this and as the reverse or the opposite of the other vector. And that brings us to the conclusion of this video. Thank you for watching. Have a nice day.